All right, let's look at one final problem from section 4.5, and that is problem number 29. They are asking you to use the upper bound theorem to find an integral upper bound and the lower bound theorem to find an integral lower bound of the zeros of each function. Okay, well, the instructions are actually pretty vague, and you could really take a lot of liberty with this. Bottom line, what they say is if you pick a number and do synthetic division, and your result in the bottom, all of the quotient and all of the remainder, if there are no changes of sign, then you know that this number must be an upper bound. Okay, so they don't say that it has to be like a tight interval that you're ending up picking. So you could pick a ridiculously large number here, and it would almost certainly be an upper bound. So for example, a good rule of thumb is you could probably choose this constant, make it positive in this case, but this constant certainly, almost certainly, would be an upper bound for the zeros of this function. So if you wanted to do that, you could. So for example, here's the number 20, and we're going to do synthetic division on this particular polynomial. Okay, so bring down the 1. 1 times 20 is 20. Add these together, we get 25. Multiply, 20 times 25 is 500. Add these together, we get 497. Multiply 20 times 497, we have 9,940. Add those together and we have 9,920. So we see that in the quotient and remainder, those are all positive. There's no sign changes in that process. So that tells me then that 20 is, is, and I'm going to abbreviate upper bound to be UB, is an upper bound of the zeros of the function that we were given. Now, if you wanted to make it a tighter range for your upper bound, I believe 2 actually will also work in this particular problem. But they don't say that you have to make it tight, so we're not going to bother doing that. Okay, so that's how to find the upper bound. So this is part of our answer. We also want to find the lower bound. Well, the lower bound, the first thing you actually have to do is find f of negative x. So that means wherever you saw an x in your previous function, replace it with negative x and simplify. Well, if you take negative x raised to the third power, you get negative x to the third power because multiplying 3 negative numbers together comes out negative. But if you take negative x and you square it, 2 negative numbers multiplied together comes out positive. So we have plus 5x squared. The sign of this term didn't change. Then I've got negative 3 times negative x. Well, the negatives would cancel, so I would have plus 3x. And then I can leave that constant alone since that doesn't change. Okay, then they say do the same thing again, only now with this new polynomial to find a lower bound. Well, again, we're just going to take this constant and make it positive. Then rewrite your terms of your polynomial, which in this case is f of negative x, and then go ahead and do the synthetic division. So we bring this down, we multiply, we add, we multiply, we add, we multiply, and we add. So notice in this case that the signs don't change as you go from left to right in this quotient and remainder. They're all negative. So then that tells me that my lower bound isn't 20, but rather it is negative 20. So negative 20 is a lower bound for the zeros of this polynomial. So that's how to use the upper bound theorem and the lower bound theorem for finding the upper and lower bounds for the zeros of a polynomial. Again, this could have been done much more tightly. In fact, I think you could have used something like -6 and found that that is a lower bound for this polynomial as well.